Hello students, in previous lecture we have solved two problems. One was related to the resistivity and one was related to the fraction of electrons which are activated. Okay, so in this lecture we are going to solve few you can say we will see few reactions. Okay, so let's start. Let's say we want to synthesize cobalt ferrite, that is CO Fe2O4. So there are different methods which can be used. For example, Solger method, co-precipitation method, or there may be another method which are, let's say, solid state reaction method. So there may be different reaction methods, but we will choose one of that is, let's say, some chemical method. So if we want to choose the some chemical method, in that case we will use cobalt source, which is, let's say, cobalt nitrate CONO3 twice dot 6H2O, that is cobalt nitrate hexahydrate, and iron source which we will use is iron nitrate monohydrate. Okay, there are two sources that we will use, and we will use a fuel. Okay, so we can write the reaction as CONO3 twice dot 6H2O plus 2 times ferric nitrate C6H8O7, which gives us COFe2O4 plus NO2 plus H2O plus CO2. Okay, we can balance this reaction, but as far there are these byproducts. Okay, these are the byproducts in the form of gas, and that will get evaporated. So initially, whenever we have to do such reactions, we have to calculate the molecular weight of each compound. Let's say this compound, and fuel which we have used is citric acid. Let's say it is citric acid, so its formula is C6H8O7. So first and foremost thing is we have to calculate the molecular weight. So let's calculate the molecular weight. So for example, CONO3 twice dot 6H2O. Okay, so CO has atomic mass 58.93, nitrogen has atomic mass 14.0067, then oxygen has 15.999, and finally hydrogen, it is 1.00794, and iron, okay, it has molecular mass 55.845. okay, so how we can calculate the molecular mass of the cobalt CONO3 twice dot 6H2 is like this. CO, that means 58.93, plus NO3, N means 14.0067, plus 3 times, this 3 times molecular weight, atomic mass of oxygen, that is 15.999. okay, and this multiplier 2, okay, this 2 multiplier is there, plus this 6 times molecular 2 times molecular mass of this hydrogen, so which is, atomic mass of hydrogen, that is 1.00794, plus oxygens, that is what is that, 15.999. so if we do the total of this, by here this multiplier 3 is because of O3, this 2 multiplier is because this, out of this bracket there is 2, and like this way if we calculate the molecular weight of the cobalt nitrate that will come. Okay, so similarly we can calculate the molecular weight of the ferric nitrate, that is FeNO3 thrice dot 9H2O. So the molecular weight of the CONO3 thrice dot twice dot 6H2O, that is 290.87 gram. Okay, so similarly if you try to calculate it for the ferric nitrate FeNO3 thrice dot 9H2O, the molecular weight it is 241.755 grams, and the molecular weight of C6H8O7, that is citric acid, it is 192.06 gram. Okay, so once we have calculated the molecular weight, our work is very simple. So our original reaction is like this: cobalt nitrate. Okay, so let's say I will write cobalt nitrate plus 2 times ferric nitrate plus okay, so there is citric acid which gives me COFe2O4. okay, so cobalt nitrate, this is CONO3. I will write it properly, otherwise that feeling goes. H2O plus 2 times FeNO3 thrice dot 9H2O plus C6H8O7, this gives me COFe2O4 plus CO2 plus H2O plus NO2. okay, so these are the gases which get evaporated as this reaction is complete. So we can see initially we have the molecular weight of this. What is that molecular weight? So that molecular weight is 290, so it is 290.87, this much gram. Molecular weight of this 2 times molecular weight of this is 1.75, 241.75. okay, and the molecular weight of citric acid, it is 192.06. okay, so what we have to do, this molecular weight plus 2 times this molecular weight plus this molecular weight we have to take. okay, so once we take that molecular weights, finally we have to calculate the, so if we cannot add this much of gram substance. So let's say we want to use 10 gram do the reaction for 10 gram reactants. okay, if we want for the 10 gram reactants, so 290.87, this divided by, for let's say weight of cobalt nitrate, that is equal to 290.87, this much gram, divided by the total mass, that is, just wait, is it same 290.87? okay, divided by this 290 plus 0.87 plus 2 times 241.755 plus this 192.06. okay, so this will give me mass of the cobalt nitrate. Similarly I can go it for the ferric nitrate. So for ferric nitrate case, I have to take the mass 2 into 241.755 divided by this whole denominator as it is. This will give me mass of ferric nitrate. okay, this is for 1 gram. If we want it for 10 gram, we have to multiply it by 10. Here we have to multiply it by 10. And similarly for the last case, that is citric acid, we can do it like 192.06 divided by this bracket denominator as it is into 10. So this will give me some value, this will give me some value. So cobalt nitrate's weight I have to take it from here, then ferric nitrate's weight I have to take it from here, and citric acid's weight I have to take it from here, I have to do these calculations by my own, and then we have to do the final reactions. Okay, so there are different ways of adding the citric acid. So sometimes we add in 1:1 ratio, so it is called as oxidizers to fuel ratio. So here oxidizes cobalt nitrate and ferric nitrate is our oxidizers, and fuel is the citric acid. So we generally maintain oxidizers to fuel ratio is equal to 1. So in that case, if this is 1 and this is 2 mole, so it will be 3 mole. So in that case we have to maintain this as 1 mole. So these different ratios are very important. So if it is 1 mole, this is 2 mole, and if we take it as 3 mole, then oxidizers to fuel ratio is equal to 1. So maintaining this oxidizers to fuel ratio is sometimes important, but okay, so why we add this fuel, that is also important. There are reactions which we complete. Okay, so when we want to reduce the temperature. Okay, so if we are performing this without fuel, we can do this reaction at 1200 degrees Celsius, but by adding this fuel we can perform this reaction in the beaker which is around which goes around 400 degrees Celsius when it is burning. Okay, so we can reduce the temperature, we get uniform particle, so desired particle size which we can get, even we get the cobalt ferrite in the nanoparticle size. So we can change the amount of the citric acid by some we can increase or decrease depending on the reactions and depending on the requirement, and like this way we can do the reactions. Okay, so there are many you can say things that we can do. So for example, if I want a compound like CO.8, okay, Fe, let's say CO.8, then sorry CO.8, let's say nickel 0.2 Fe2O4. Suppose I want to synthesize such compound, so in that case 0.8 times molecular weight of cobalt nitrate, 0.2 times molecular weight of nitrogen related nitrate, nickel related nitrate, plus 2 times ferric nitrate, plus 3 times whatever citric acid is there that we can take. If we have taken this weight, one weight, second weight, third weight and fourth weight, we have to add these four weights, and let's say 0.8 times cobalt nitrate's weight divided by these total weights, these four weights, into 10. This will give me the weight of the cobalt nitrate that I have to add to perform this reaction. Similarly, 0.2 times weight of the nickel nitrate related compound divided by total weight into 10. This will give me the weight of the nickel nitrate related compound. Similarly, 2 times this ferric nitrate divided by total weight into 10. This will give me weight related to the ferric nitrate, and finally for citric acid 3 into citric acid this divided by total weight into 10. This will give me weight related to the citric acid that I have to add to complete that reaction. So like this way I can, by using this method, we can form different compounds of different stoichiometry. So with this I can stop here. Thank you for watching.